This is 8.7 part 2 of pre-algebra math class worksheet. Today, a lot of notes to take students. So
today
we
we're
have
going
12 points
to
here
do
classwork. Well, not that many notes. We only have 8 points here.
We have 32
this is
points here
of
classwork, and then 9 points.
Function notation. And this is a notebook entry here. Writing a function, example 3. Write a linear function g given that g of 0 equals 9 and g of 3 equals -6. So to find the slope m of this function here that connects these two lines, you can tell from g of 0 and g of 3, you know that the graph of g passes through the points 0, 9. This is x, this is y, 0, 9. And then 3 and -6. This is x and this is y here. So now we can find slope. And this is our slope formula. It would be -6 minus 9. And then 3 minus 0. That gives us a -5. So there is our m there. And we know this here is our y-intercept. So the y-intercept via the function's graph. The graph passes through 0, 9, so b equals 9 for this line up here. So an equation would be -5x plus 9. This is positive 9 here. So it'd be -5x plus 9 would be an equation of the line that connects these 2 points here. Okay, write a linear function that satisfies given conditions. R of -7 equals 3, and then r of 0 equals 3. Same thing down here. Write a linear for those 2 points. We'll do the guided practice here first, and then here is our plug-in. 3 minus 3, and then 0 minus 7. And we have a slope here of 0, so it's a horizontal line. B equals 3, so we have 0x plus 3. R of x equals 3. So that would be the equation of this line here. Both of these have the same y-coordinate, so it is a line. And then down here, students, that's on you. Example 4, using function notation in real life. A balloon raises at a rate of 500 feet per minute to a final altitude of 120,000. Use function notation to write an equation giving the altitude of the balloon as a function of time. So let t be the elapsed time in minutes since the balloon was launched, and let a of t be the altitude in feet at that time. Write a verbal model, then use the verbal model to write an equation. So altitude equals rate of climb times time. So the rate times time. And our rate is what, 500 feet per minute? And then time is, do we have a limit here on time? Doesn't look like it, just minutes here. So A of t would equal 500 t. So it'd be 500 t a minute per minute, 500 feet per minute. So that would be your function there for altitude as a function of time. Find the value of t for which A of t equals 120,000. So A of t equals 500t. Write a function for altitude. We know it raises at 500 feet per minute, and t is in minutes. So 120,000 is our A of t. That is our altitude of time. I guess our maximum altitude. So how many minutes does it take to reach that would be the question. So it would be 240 minutes for it to reach this altitude here. Divide each side by 500. So they took the balloon about 240 minutes, or about 4 hours, to reach this altitude there. And that is your example 4. Now we have a arrow squid. Has the beak used for eating. Given the length b in millimeters of an arrow squid's lower beak, you can approximate the squid's mass using this function here. So this, you can estimate a squid's mass by this function here. And then we have this stipulation here where it is found and measured by a biologist. Lower beak has a length of 5 millimeters. Approximate the mass of the squid. And then down here to the nearest tenth, how long is the lower beak of a squid with a mass of 1100? So you just plug that in here and then solve for B. But this one, lower beak, has a, they're giving us a length here for B. B is length. So we plug B in to that function to find mass. Mass is a function of the beak length. So m of B equals 236B minus 513. We know the length of the beak is 5 millimeters. So we can find our mass. Our mass is 667 grams with that size of beak. And then down here you do, I'm going to let you do that one on your own. And that is 8.7 part 2. Class work. Thank you very much.